Maybe that day, the work day, you will work on homework, whatever, okay? Because remember, you can work together on the quiz. You can use your notes. This is 2-1 and 2-2 is a bunch of formulas and plugging in correctly. I would 100% take that quiz with my notes, with my formula sheet in front of me, and, make sure your first quiz is a good grade, okay? So what I want to remind you of, wait, I had to show you one more thing. Since the 9 weeks grades are done, I'll do this all year. I want you guys to see just overall how people did on my quarter grade for this class. So in all my classes total, 61 A's is a lot, 45 B's, 25 C's, 3 D's, and only 2 F's. So that's really, really, really good. So keep up the good work. I won't give you the whole speech again, but just remember, if you're more to the left here and you're happy with where you are, hey, of course you're happy. Keep doing what you're doing. If you're further to the right and you want to be further to the left, think about what you can do to change to get your grade up, okay? So that is that. I also noticed that many of you did not many of you, some of you did not do the progress monitoring check. Even though it's been open for over a week, I reminded you, I gave you class time. It's a homework assignment, so I did open it again to give you the possibility of getting half credit by completing it. So if you did not complete it or do it, go in and do it by Sunday at midnight, okay? It's worth 10 points, but half is 5. So it's still not a great grade, but it's going to be better than 0, okay? All right, so yesterday we did arithmetic sequences, and we compared how they have a relationship with linear functions. All the examples we're doing today are identical to yesterday's examples. You're going to hear me say, and just like yesterday, or different from yesterday, because today we're doing the same idea, but we're learning how exponential functions are related to geometric sequences. So if you remember, a geometric sequence is multiplying left to right. If you graph, and this is an example of a geometric sequence, if you graph a geometric sequence, it'll make a graph that's not a line like yesterday. It's going to make like a curvy graph. It's called an exponential function. It will look like a J or a backwards J. It's got this little dip in it, okay? So this is an exponential function. These are the points graphed. And we could pull the points right off of the graph and fill these blanks in. But let's use our other way of finding, continuing in this chart, which is we want to know what we're multiplying by as we go left to right. And you may not be able to tell what you're multiplying by, so we need a way of testing that, and that's going right to left. So in dividing, doing the opposite of multiplication. So 32 divided by 64, put it in my calculator, you can get 1/2 or 0.5, it doesn't matter. So our R is 1/2, and we're just going to multiply left to right by 1/2. When you multiply something by 1/2, it actually divides it by 2. So we're just dividing by 2, whether you do it in your calculator or in your head, that's what the chart would end up being. Okay? Next question is find the common ratio. We already did. It's 1/2 or 0.5. Either one doesn't matter. And write an explicit rule. So nothing we're doing today, anyone is going to be like, this is so hard. Nobody's going to say that. The thing that's confusing in yesterday and today's is just knowing when you write what in which formula. Okay, that's the hardest part. So let me remind you of the formula for the explicit rule. It is A sub n, I'll get it in a second, equals A sub k times r to the n minus k. Can you see that? N minus k. Okay, and so we're going to write that. Remember, no matter which one we're talking about, arithmetic or geometric, when we write the explicit rule, we leave n empty. We don't put anything in for n, either n. And a sub k can be any one of these numbers. It doesn't matter, but I'm going to tell you in a second why. Let's all choose the first term. Let's be boring like me and use the first term, which is 64. The r we already found is 1/2 or 0.5, doesn't matter. We never plug a number in for n. And then k is whatever term this is. So what k is this? 1, right? And if you remember, when we did this same problem yesterday, we had to simplify. You can simplify an arithmetic explicit formula by distributing and then combining like terms. The good or bad thing, however you want to look at it, about geometric ones is there's no simplifying. Once you plug in, you're done. That's why I like for us to use the first term, because that's what my key is going to use, and that way you can check your answer correctly. But technically, you can use any a sub k, just like I said yesterday. It's just that there's no simplifying in this, so we won't see that we all got the same answer, right? So you could technically, for example, put an 8 here, and then k would be 4. I could put a 1 here, my k would be 7, okay? Just like yesterday. A sub k can be anything, but for this, let's just use the first term, right? Now, just like yesterday, we're going to write it in function form. So we just wrote the explicit formula for geometric. Let's write an exponential function. I'm just taking it right off of your exponential function box that we just updated here. So Fernando, you'll have to catch up with that. And so what we need when we write this formula, and look, notice me changing how I do the letters. It means the same thing. Instead of f of x or y, I'm using f of n just like yesterday. Why am I using n in place of x? Because n is what they use for x, so I'm just using the same letter as they did. Okay, here's what's really important to know. A in this formula is very specific. It has to be a sub 0. A sub 0 is your y-intercept. Okay, so when we write this in algebraic form, exponential function, when this part of the problem, a sub 0 100% of the time. And then b, guess what, is the same as r. Just like yesterday. B and r are the same thing, just like m and d were the same thing yesterday. So we already have this. It's 1/2. We don't have a sub 0. Like many times yesterday, we didn't have a sub 0. Multiply it by 2, we go backwards, right? If we know a sub 1 and we have a b value, we just go in the other direction. And don't overthink it. It's like, oh, am I multiplying by 1/2, dividing by 2? What am I doing here? Just look at how your numbers are trending. They're going down when we go left to right. So just like I think it was Zach said that, it's going to get bigger as we go right to left. So you're going to multiply by 2. Okay? So that would be 128. 64 times 2 is 128. And now you can write your final answer. F of n equals, there's my a value, there's my b value to the power of n. All right, now I want to make sure you guys, I want to compare this because this is the only thing that we can get confused on here. Look at those two formulas. One is the explicit formula and one is like the algebraic form. They're super similar. First thing that let's talk about the two things they have in common. They both have the same number in the parentheses. Whether you call it b or r, it's the same number. They both have something to the power. Now let's talk about the two things that are different. The first number in both of them is different. Remember, this is a sub k, which we're going to use a sub 1, even though it doesn't really matter. And this is always going to be a sub 0. And look, in the explicit formula, we have that -1. In this one, we don't. So think ahead to a multiple choice question where you have, this is the answer, this is the correct answer, but you have a choice in there thrown in with an n-1. Okay? You have to know the differences in these formulas and when am I putting a -1 and when am I not. And we'll cover that more in the coming examples, but that's something to think about. Okay? All right, let's look at the next one. Just like yesterday's second example, we have some terms, some put in a chart, and we need to finish it and state our domain and range, okay? So yesterday, when we did this problem, we had 2 points, and we found the slope, or AROC, because what we learned yesterday was slope and D was the same, and what we need is the D in those problems to go left to right. So we used our slope formula, found the slope, and we had just added that number left to right. Well, we can't use the slope formula in a geometric sequence. There's no slope. This is where we use a different formula. Do Do you guys remember how to find a number in the middle of two others? Not midpoint, geometric mean. Geometric mean, we're going to do the square root of 144 times 36. Remember, that's when we're trying to find the middle of two numbers. And if you want to write that on your formula sheet, how to find the middle. Like, I didn't write that, but you can write anything you want on here, okay? So when I put that in my calculator, I will get 72. Now I can find R or B, whatever you want to call it. I can find R by doing any two consecutive numbers. It doesn't matter what two. So I could do 72 over 144 or 36 over 72. It doesn't matter. I'll get the same answer. Put it in my calculator. Remember, how do I change a decimal to a fraction? I'm going to do math, enter, enter. So 36 divided by 72. Our calculators default to a decimal. And this is fine too. You could leave it at 0.5. So I shouldn't have said that you have to change it. And I don't think you guys need a calculator to change 0.5 to a fraction. But just to review, math, enter, enter would give me 1/2. So you can put 1/2 or 0.5. It does not matter. So you can see our numbers are getting smaller as we go left to right. So keep that up. 36 divided by 2 is 18. Divided by 2 is 9. 9 divided by 2 is 9/2. Or you could do the fraction version, which is decimal, which is 4.5. It does not matter, okay? So if I have 9/2 in my calculator, I'm going to now divide it by 2. Again, I multiplied by 2. 9/2 divided by 2. I would get 2.25, which is totally fine, or I could do math, enter, enter, and get 9/4. Why do I keep showing you both when it doesn't matter? Because when you take multiple choice tests and you have a choice, 4 choices, and they're all in fraction form or they're all in decimal form, you need to know how to access the fraction version of something or the decimal version of something. So that's why I keep pointing out both of them to you. All right, so we just finished the chart, and guess what? There's my domain, there's my range. Remember, just like yesterday, that this is not a true exponential function. If I graphed it, it would look like one of these J's, backward J's, but we would not connect all the points. They are discrete points, just single points graphed on the coordinate plane. So when we list our domain, it's listed just like this with commas, 1, 2, 3, not the numbers in between. So remember, we do not ever put sequences in interval notation because it's not all the numbers in between 1 and 7, including the numbers between 1 and 2 and 2 and 3. It's just 1, comma, and 2, comma, and so on. Okay? That's the only difference. Now, just like yesterday, let's take the information in example 9 and write it as an exponential function. Understand the language. Exponential function, that's this guy. If it said explicit formula, it'd be the a sub n. But it said exponential function. So A, remember, is very specific. It has to be a sub 0, and B is the same as your R. So f of n equals, we need to find a sub 0. We have a sub 1, just like the last one. We need to go this way. The numbers are going to get bigger, so I'm going to multiply by 2. So 144 times 2 would give me a sub 0, which is, nope, what is it? 288. Sorry, it's 288. My B value is the same as the R. Remember, these are the same thing. And exponential functions, we don't subtract 1. Okay? This should look familiar, just like yesterday. Here's the graph of an exponential function, and we can fill in this table using that graph. They also listed the numbers here. So these are like ordered pairs. To the right 1, up 3, to the right 2, up 6, 12, 24, 48, 96, and so on. And remember, subscript, this is a language we're learning and understanding. We should be able to write it, read it, see it, and understand it. Subscript notation is when we do our explicit formula, right? A sub n and A sub k's and A sub 1s. So when we're working with sequences, we use subscript notation. And then function notation is good old algebra. Slope-intercept form, or the exponential function we just wrote, right? F of x, f of n, f of 1, f of 2, and so on. So they mean the same thing, but we use different notations in different problems. So let's write this exponential function. Look at how it's a J, kind of like a J, whatever. And subscript notation, remember, that's our explicit formula. That is A sub n equals A sub k. I'm writing it again. You can choose to or not. The more we write it, the better it gets cemented in our brain. And again, we can use any A sub k we want, just so that we have the same answer. We're going to just use the first term. So that would be A sub n equals, the first term is 3. What's our r? Multiplying by 2. So r is 2. And then we have n minus, this was our first term, so 1. And remember, there's no simplifying to do. Yesterday, we would have had to distribute and do all that stuff. That's it. Function notation is like your algebra, okay? F of n equals a times b to the n, where a is a sub 0. Has to be. So again, we have a sub 1, we have an r value. If we go backwards, our number is going to get smaller, right? So you're going to divide by 2. You can either get 3/2 and leave it like that, or 1.5. It doesn't matter. 3/2 or 1.5. That is my a sub 0, my y-intercept. B and r are the same thing. No subtraction in that one. We getting this? Yeah? Raja, you paid attention? All right, last question. Just like yesterday, we're given an explicit formula. We know that is. We should, without the directions, we should be able to look at that and go, that's an explicit formula. And I think that's a typo. I think that should be a sub n. I think that's what she meant. Because of the subscript and the -1. That's when we have the minus there, we know that that's a explicit formula. Plus, we know it's geometric and not arithmetic because it's got an exponent in it. Anyway, write the first 6 terms, just like we did yesterday. 1, 2, 3, 4, 5, 6. So let's pull some information out of here. There's 2 numbers, 6 and 1/2. We should be able to say what they are. Well, let me answer that by talking about this first. If we have 6, what term is that according to this? The first one. So a sub 1 is 6. So I'm just going to call that the first term. Okay. When we get to a word problem in our homework here in a minute, I'll remind you when you want to use a sub 0. And the other number, 1/2, would be our r, right? So now I know I'm going to multiply by 1/2 as I go left to right. So 1/2 of 6 is 3. 1/2 of 3 is 3/2. Or you could go into decimal land. Okay, fractions or decimals are fine as long as I'm not rounding. And as I go through these in my calculator, I left them in fraction form. If you left them in decimal form, that would be okay, or just steal my answers. But no, I did that on my calculator. I divided each one by 2, math enter, enter, divide by 2, math enter, enter, divide by 2, math enter, enter. I liked fraction form, decimals would have been fine. Okay, find the a sub 0 term. So remember, we called this a sub 1, so a sub 0, it would be 12. We would do 6 times 2. And write the exponential form. Language, that's this business. Exponential form, not explicit formula. Same letters, EF. Explicit would be the a sub number. So exponential form, I need a sub 0. Yay, we just found it. B and R are the same thing. No subtraction. So instead of doing the word problems in the notes, I'm going to do the two of the 3 word problems in the homework with you right now. Okay? So I'm going to do homework with you, and I would do it with me so I can show you some fun little things. Page 23. I'm going to go over to page 25 and do number 11 and 12 together. Please do them with me. Please, please, please. And then you'll have time to work on the others, so press the key up. Okay, for number 11, a culture contains 10,000 bacteria initially, okay? So a culture, some sciencey thing, whatever, of 10,000 bacteria initially and increases by 20% every hour. What we need to do is find a formula for the number n of t of bacteria. Guys, that's code for the algebra version, right? That's written in function notation, f of n, j of x, whatever, n of t. So I know if I'm going to write something in that formula, I need a sub 0 and I need b, which is r, right? They mean the same thing. So I know that whenever we hear the word initially and in word problems, that means a sub 0. It's what you have or what you start with before time starts. So here is 10,000 bacteria. And now every hour it's going to get more, increase by 20%. So that's when we add to 1. So guys, whenever you're given a percent, you should know that that makes it geometric immediately. You know it's geometric. And we always change percents to decimals. Okay? So how do you, what? Yep. So, but remember on the formula sheet, I zoomed way in a word problem, you sometimes have to add or subtract your R or B, whatever you want to call this, we'll call it both, from 1. If we're increasing, you would add it to 1. So this would be 1.2 or 1.20. What that means is we took 100% of what we had at first and added 20%. That's 120% changed to a decimal, which is 1.2. Okay? And I'll tell you how that can help you how it can make sense in a second. All right, so n of t equals a sub 0 times 1.2. What letter am I going to put up here? No. T. Right? This is like your x. You want these letters to match. Am I going to subtract 1 on this one? It matters. No. Haley, you're right. No. Guys, function notation, no. The algebra version, it's only when you do a sub n. Remember, because you have a sub k, and then k is what you subtract. Think about it. All right, how many bacteria in the culture after 10 hours? Well, that would be T is 10. So what we're going to find is n of 10. I'm going to go to my calculator. 10,000 times 1.2 to the 10th power. Should my number be bigger than 10,000 or smaller? A lot bigger. We're increasing, okay? So we get 61917.364 bacteria. We're increasing. So my point of pointing that out to you is a common mistake here would be just putting 0.2 in there. This number would have ended up being smaller than 10,000. And so if it's increasing every hour, this number better be bigger than what our initial amount was. So things like that, little clues, can help you catch a mistake. Oh, that's right, I was supposed to add 1 to that. Okay. A rubber ball is dropped from a height of 25 feet. The ball bounces to 80% of its guys, come on, don't be rude. I'm almost done. Let me start over. A rubber ball is dropped from a height of 25 feet. The ball bounces to 80% of its previous height with each bounce. Okay, so let's dissect that information. There is a ball 25 feet in the air. Before any time has gone by, before I drop it, that's the initial height. It didn't give us a hint of saying the word initial in there, but it makes sense in the context of the problem. And bounces to 80%. Think about common sense. When you drop a ball, just think about a basketball. You drop the ball. Does it bounce up to exactly the same height? No. Does it bounce up to higher than your initial? No. It's going to go lower every time, right? It's going to be a little bit lower. So 80% change to a decimal is your R or your B, whatever you want to call it, okay? So in that case, you have to read carefully. Am I adding and subtracting this one? No, the way it was worded, it's bouncing up to 80% of the 100% the previous one. So it's already been subtracted for us. So now that I have this information, how do I find the first term? Yeah, multiply 25 times 0.8. That will give me 20. That answer makes sense. Keep multiplying by 0.8. I know these numbers should be getting smaller. These numbers make a lot of sense. Write an exponential function. They even gave us the form. F of n. A is a sub 0. We have to know that. A sub 0, 25. R, B all mean the same thing. No subtraction. So n is your number of bounces. H of n, F of n, whatever you want to call it, would be the height. So what is the height after 10 bounces? We can put that in our calculator. And we get approximately feet. What is it? Yes. Last part is a really good AP question. When will the ball bounce less than 1 foot high? Any ideas of how we would find that? Okay, Zach. Okay, we're getting closer. You guys are really thinking. I love it. What they're asking for is, and we're going to do it in a second. Here's the graph. It's going to make like a curvy graph like this. You'll see it on your thing. The question is, where on this x-axis does this happen and everything below it? This is when we use our intersection. This is asking for what is x when y is 1 or less. So we can't use our table. Using this is not going to be very accurate. So do me a favor, though, and clear your RAM so you can do it fresh, because the people before you already did it. You don't want to just use their stuff. You want to know how to do it yourself. So here's what we're going to do. We're going to use our intersection. Let's type in, and we don't have an n. X is fine. So I put in y sub 1 is 25 times 0.8 to the x, and y sub 2 is a horizontal line of just 1. So I'm just going to put in 1, because we want to know when it's below that. Let's graph it and see what it looks like. Because remember, sometimes we have to change our windows, sometimes we don't. Because to be able to do the intersection or the min or the max or the zeros, we have to see that thing. I don't see that thing, right? I need to move my window to the right. Go to window. Which one of those moves my graph to the right? X max. What do we switch it to? Technically, I don't necessarily know that every time. I try something. I feel like I'm pretty close. Let's try 30, try 50, try 100, try 25, try whatever you want. You can always change it. It doesn't take long to hit those buttons. As long as your window now is showing your intersection, we're good, okay? So where is intersection? Where do I find that? Remember you had to put the 2 in? Y equals 1, horizontal line, y equals 1. Okay, so where do I go to find intersection, guys? Calc. Remember, calc, it's blue. That's where my min, my max, my zero, my intersection, number 5. So 5. And it always puts my cursor in a good spot right to begin with. I'm going to hit enter. First curve, yes. Right arrow, it's always going to go onto that horizontal line. Anywhere over here is fine. Remember, as long as you're to the right of it, hit enter again. Do you want me to guess? Yes, please. And it'll show you when y is 1, x is 14 point blah, blah, blah. So this is the way I answered it. Y is less than or equal to 1, because we're on the line right now at approximately 14.425 ounces. It's a weird way of answering it. And I don't want you to stress too much in homework as far as how to answer it. You guys know when it comes to a test in this class, I give you a review where I model for you exactly how you would answer the questions. When you take the AP exam, we will have taken 4 or 5 mock exams together where every single FRQ is exactly the same. You will know how to answer every single question. So don't stress too much about it. Like, does it make sense to have decimal bounces? No. But we're just kind of answering it quick. Okay? Now you can go back and work on the other ones. I will put the key up and answer questions if you have them. Can I take this down? Okay.